But nobody no come on it. It's just that me want to see how we go.
Yeah, but if the audio is on,
How we do it? How we do it again?
And somebody, she's a beauty.
Yes, you know, come over.
so this is on Facebook right now.
Mm-hmm.
You sure?
Yes, it's on Facebook.
Okay.
Oh, 605. That is not 605. So you're seeing yourself like you ought to. You're not seeing this. Right?
Mm-mm.
You can't add to that.
Hi everyone, thank you so much for joining me this evening. I'm going to be starting shortly. Hi, good evening again to everyone who have joined me. We're going to be starting shortly, just trying to get some things together right now, but we're going to be starting shortly. Hi, Styles on Edge, how are you doing? Hi, Josset, how are you doing? Nina, how are you doing? Miss underscore Lala 14, how are you doing? Thank you for joining me. All right, so I think I can go ahead and get started right now. Oh. All right, so this evening I'm going to be going through a couple of the topics that will be on the competition coming up shortly. So I'll be talking a little bit about inequalities today. I'll look at fractions for those students in the 10 to 12 year group. And then I'll also talk a bit about functions as well for those in the 15 to 17 year group. So I'm going to talk about those three topics. So please stay tuned. And of course, I'm also going to share some information about the competition with you as well so that you can have an idea of what to expect on the actual day of the competition. So first, of course, I want to thank all of you for joining me this evening. In addition to that, I also want to thank all the persons who have already signed up to be a part of the competition. So I know that for a lot of students, you might be a bit confused about how we will run the competition. But we're going to be hosting practice sessions with you guys prior to the competition so that you are aware of the rules and the expectations and things like that. So stay tuned for all of that. Continue to monitor our social media platforms and you will see information about that. We will also be reaching out to you via email as well to let you know when we will have those sessions. I also want to thank our sponsors who have already come on board to support us in this competition. So I would like to thank Miss Nicola Myrie, Mr. Dennis Wright, Miss Lashana Morgan. I would also like to thank Miss Ruth Porter and Miss Daislyn Facey, who have come on board to support the competition. And of course, if there are any other persons who are interested in supporting the competition, you can always reach out to us and we will be really happy to accept your assistance. All right, so in terms of some of the benefits of the competition, for one, it will give you some amount of exposure, but two, it will also assist you, especially if you are someone who is working to improve your math skills, whether it's for PEP or CSEC, if you're doing like a GED or whatever it is that you're doing. You could be a person in school who needs just, that extra boost or that extra confidence with your math skills. Even though it's a competition, it will sort of assist you as you navigate through. So those are, I would say, some of the benefits of the competition. And of course, remember that the winner for each section will get 30,000 Jamaican dollars for that prize. So if you are that lucky person, you will walk away with 30,000 Jamaican dollars. And again, there are three categories. We have the grade 4 to 6 category. We also have the 7 to 8, so those in 7th and 8th grade, and then we have the 9 to 11 category. So if you're in grades 9 to 11, because typically around grade 9 is when you start really practicing CSEC type math. So that section would be for those students. I would also encourage other persons to apply for the competition. We have extended the deadline, so now the deadline is the 7th. So you still have a few more days. Today is the 4th, so you still have about 3 more days to submit your applications. Do not be scared. These are questions that you guys are familiar with. These are topics that you're also familiar with as well. So just make sure that you go ahead and you fill out the application. And of course, we will reach out to you in a timely manner. As I've stated before, we will clear up any misconceptions, any confusions as we go along. So that you will know exactly what to expect. You'll understand what the expectations are, the guidelines, and so on. And it will be easy for you, of course, to pretty much participate in the competition. It will be done via Zoom. So we have a couple protocols in place. And again, you will be duly informed about those different protocols. In addition to that, if you have like any additional questions for right now, you can feel free to ask them. So as I've stated before, I'm going to be looking at 3 of the topics that you will see as it relates to the competition. So for the age group 10 to 12, I'm going to talk a bit about fractions. Fractions never go away, no matter how like high up you are in terms of your academic pursuits. You will still see some amounts of fractions, whether it's basic multiplication or division and so on. You will still see some amount of fractions in your calculations and so on. Also for the next level year group, you will also see questions related to inequalities. That is something that you will see typically. You see that in the 8th grade. You'll see that in the 9th grade and so on. Even beyond, you'll still see inequalities. Even, of course, some of the CSEC questions, there will be inequalities. So I'm going to talk a bit about that. And then the last thing is that we're going to look at a bit of functions, because that is definitely something that you will see at the CSEC level. So without further ado, I'm going to get started. All right, so I'm going to start out with some problems having to do with multiplying fractions, and then we'll look at some division of fractions. And again, this is really geared towards those younger students. If you're in grade 4, grade 5, or grade 6, then this is definitely your area. So you will be seeing questions with fractions, and I want to say that one of the things that we're expecting as well is sort of speed. So how fast are you able to work these problems out, and so on, or how accurate are you when you work problems like these out? So typically with fractions, if you're multiplying fractions, you can approach it two ways. So for example, if I had, say, 3, let me write that a little bit brighter. Okay, so if you have 3 over 4, let me make sure that it's showing on both platforms. I might need to change the position. Okay. All right, good. So say, for example, if I have 3 over 4, so 3/4, and I'm multiplying 3/4 by, say, 6/8. So for this one, as you can see, I have my numerator, my denominator here, my numerator, denominator there. There are two ways that you can approach this problem. Some people prefer one way over the other. But of course, if you're multiplying fractions, you can either multiply across. If that's easier for you, that's one approach. Or you can simplify before you multiply. So you can multiply across, then you simplify. Or you can simplify, then multiply across. So for example, I could do the first way where you're just multiplying across and then simplifying. So 3 times 6, that would be 18. And I multiply my denominators 4 times 8, that gives me 32. So now my fraction is 18 over 32. But a lot of times they actually want you to pretty much simplify your answers. So this, even though it's correct, they typically want you to simplify the result that you get. So here I have 18 over 32. So if I simplify this, I would just pretty much find the HCF, which is the highest common factor of both of these. And once I find my highest common factor, I use it to simplify this fraction. So I have 18 and 32. I can use, let's see, I can use, so I have 18. I can actually use 2 to simplify here. So that would give me 9. If I did 2 into 32, that would give me 16. So my final answer would be 9 over 16. So 2 in this case is the highest common factor of 18 and 32. So that would be my final answer, 9 over 16. I could also approach this another way if that's an easier option. So I could have 3/4 multiplied by 6 over 8, and instead of multiplying across and then simplifying, I could actually simplify first, meaning that I would find the number that I can use to pretty much simplify this fraction. So looking at my 3 and my 4, looking at my 6 and my 8, I'm looking at my numerators, comparing it with my denominators, and then trying to figure out which number will be able to cancel a number in the numerator with a number in the denominator. So looking at 3 and 8, I realize that they do not have any common factors. But if I look at 6 and 4, they do have common factors. So I can go ahead and, of course, divide 4 by 2, divide 6 also by 2, and that would give me 3. So now, since I have no other factors between my numerator and denominator, what I would do is that I would have 3 times 3, that would be 9. And then 2 times 8, that would be 16. So again, it still gives me the 9 over 16, but again, 2 different approaches. Whichever one you choose to use, that's fine, as long as you arrive at the correct answer. And of course, you understand what you're doing. So you can either, again, multiply first, then you simplify, or you can simplify before multiplying. Simplifying before multiplying have its benefits, because once you simplify before you multiply, it makes it easier for you. Because sometimes you can get some really large numbers and it takes a long time for you to simplify. So simplifying before sort of gives you an opportunity to make the numbers or convert them in their simplest form, so that when you multiply, you no longer have to simplify. So either approach 1 or 2 is fine. Whichever one works best for you, I would encourage you to use that approach. And of course, these are the kinds of questions in the fraction section that you will get. All right, so that's the first thing I wanted to show. So this is just an example of multiplication. I'm going to now go ahead and work an example with dividing fractions. So let me just erase this. All right, so as it relates to dividing, it's kind of similar to multiplication. So for example, if I had, just come up with a random number here. So if I had, say, 15 over 25, and I'm dividing 15 over 25, 15 over 25 divided by, and I can divide 15 over 25 by 3 over 10. So this is what I'm dividing. 15 over 25 divided by 3 over 10. So of course we know the popular acronym that is used when you're dividing fractions. So we have our KCF, and what this stands for is keep, then you change, you flip. What that means that you're keeping your first fraction. So I'll just rewrite this as 15 over 25 because we're keeping that portion. C for change, meaning that we're changing the sign. So what I'm changing here is that I'm changing the division to multiplication. And then, of course, the flip, meaning that I'm inverting the second fraction. So instead of having 3 over 10, I would end up with 10 over 3. So that's the concept of flipping or inverting. So once I have that, then I can go ahead and either simplify first, then multiply, or I can multiply and then simplify. So pretty much as long as you carry out this first step, when you're dividing fractions, as long as you carry out your first step, after carrying out that first step, that is when you can either multiply across, then simplify, or simplify first and then multiply across. Personally, I prefer to simplify first because, again, it makes it easier. So I'm looking at 15 over 25 multiplied by 10 over 3. I can use 3 divided by 3, which gives me 1. 15 divided by 3, that gives me 5. Then I can use 5 into itself one time, 5 into 25. That gives me 5. And then, of course, I can also use 5 into itself one time, 5 into 10, 2 times. I know it sort of gets messy over time, but if you're following your cancellations, then you will see exactly what your next step is going to be. So in this case, when I'm done, all I end up with is 2 times 1, which is 2. And then I have 1 in the denominator. So it's really 2 over 1, which is simply 2. So 2 in this case would be my final answer for the 15 over 25 divided by 3/10. But again, for this one, you could actually do 15 times 10, which would give you 150. And then 25 times 3, which would give you 75. And then 150 divided by 75 would give you 2, which is kind of easy because you know that 75 is a half of 150. So in this case, it would work out pretty easy. But again, you can either choose to do the cancellation first or do the simplification first, and then you multiply across, or you can also do it the other way where you simplify first and then you choose to multiply. So again, this is something that you'll definitely see. These are some of the kinds of questions that you will see. As you can see, I believe in the when you filled out your application, a list of different topics were posted to kind of show you that these are the topics that are coming. So especially if you were like a 4th to 6th grader, these are the kind of maths that we expect you to know. So that's the reason why I'm going through fractions as examples. So this is the second kind of fraction that I want to show you. And then the last thing I'm going to kind of look at now is going to be where you're actually finding equivalent fractions. So if I give you a fraction and ask you for to give me another equivalent fraction, then that should be something that you should be able to do pretty easily. All right, so say for example, I'm going to start off pretty easy. So say for example, I gave you say 3 over 5, and I asked you to give me an equivalent fraction for 3/5. So looking at this, there are so many different equivalent fractions that you could come up with. So if you give me any particular number and it's an equivalent fraction to 3/5, that's correct. For example, if I ask you for an equivalent fraction here, you can give me 6 over 10, or you can also give me 9 over 15, and so on. As long as it's an equivalent fraction, it's acceptable. So how do you get the equivalent fraction for 3/5? So pretty easy. In order to get an equivalent fraction, you look at your numerator and your denominator. And all you're doing is that you're multiplying the numerator and the denominator by the same number. So for example, in order to get 6 over 10 or 6/10, all I did was that I multiplied that by 2 and also this by 2. So whatever I multiplied my numerator by, I'm also multiplying my denominator by that same number. So I have 3 times 2, which is 6, and 5 times 2, which is 10. So same thing here. I multiplied this by 3 and also this number here by 3 in order to get 9/15. So 3 times 3, which is 9. 5 times 3, which is 15. So in order to get an equivalent fraction, all you're doing is that you're identifying the fraction of interest, and then you're choosing to multiply it by any number. And of course, whatever number you multiply your numerator by, you multiply your denominator by, and you can get as many equivalent fractions as you may need to. So that's it for this one. So again, if you get like a fraction like say 7 over 19 and you're asking an equivalent fraction, same principle, you're just multiplying numerator denominator by the same number. All right, so I looked at equivalent fractions. I think I wanted to touch on another thing as well. Oh, so one more thing that I'll touch on for the 4th and 6th grade level. And what I'm touching on here is converting a mixed number to an improper fraction. So again, I do expect students to be able to convert mixed numbers to improper fractions. So if I give you something like 7 and say 9 over 14, 7 and 9 14th, and I ask you to convert that to an improper fraction, you should be able to do this in a few quick steps. So in order to do this, you keep your denominator the same. So your denominator here is 14. So you keep the denominator. However, what you do is that you multiply and then you add. So you have your whole number components here. You have your fraction, which is a 9/14. So all you're doing here is that you're multiplying the whole number by your denominator and you're adding the numerator. So really all you're doing is multiplying, then add. So you'd have 7 times 14, and then you add 9 to that. So in this case, we have 7 times 14. So 7 times 4, that gives you 28. So we have 8 carry 2, 717 plus 2. That's, what's that, 9? 7 4 is 28. 8 carry 2, 717 plus 2. Yeah, so 9. So it's 98, but we're adding 9 to that. So we end up with, so we have 99,107 over 14. And that right there would be like the final answer. So just to double check here, so I have 7 9 14, 7 times 14, 7 4 is 28, 8 carry 2, 717 plus 2, 9. But I'm adding my 9 here, so I have 98 plus 9. So I can do 99,107 over 14. So that there would be the final answer. So again, quick steps once you're converting a number that's a mixed number to an improper fraction. All you need to do is keep your denominator the same. You multiply the whole number by the denominator, and then you add your numerator. And once you do that, you just put everything over the denominator, and that would be your final answer. So again, it takes speed. But if you understand the concepts, if you know exactly what you're doing, it shouldn't be too hard for you to figure out what the answers are. So it won't be anything that's too technical where it's going to take you a long time to respond to a question. It's going to be questions that are testing your understanding, like, fractions, whether it's a mixed fraction, equivalent fraction, and stuff like that. So these are going to be questions that you can answer within like 10 to 15 seconds, pretty much 20 seconds max. So speed is important. So if you understand the concepts, it should be pretty easy. All right, so moving on to the next section. So I think this one's the age group 13 to 15. So I just talked about possible questions for the age group. Possible questions for the age group for 10 to 12. So if you're, like in that category, which I know a lot of students are in that category, just make sure you know your fractions, and you'll be good. But of course, it's not just fractions. There's going to be decimal, converting like a fraction to a decimal back to a fraction, being able to multiply by 100, by 10, by 1,000, knowing how to move your decimal point. So it makes it easier for you to do it. So of course, if you're multiplying by 10, you move your decimal point one place to the right. If you're dividing by 10, then you'd go the opposite way, decimal point one place to the left. By 100, two places, right or left, depending if you're multiplying or dividing. 1,000, three places, and so on. So again, if you know how to do these kinds of maths, you will be fine in the competition. So these are questions that will be pretty simple, but again, it's testing your core knowledge to see if you understood the stuff that you learned in grades 4, grades 5, and ultimately grade 6. All right, so moving on to the age group 13 to 15. So one of the topics on in that section was inequalities. So with inequalities, typically you would have like a number line, even though of course you're not going to have number lines. I don't expect you to be able to do problems with number lines and be able to successfully demonstrate that if you're answering a question. But just to refresh your memory, normally when you have a number line, you have the central point, which is 0. And then of course, towards the right, you have positive values. And towards the left on your number line, you have negative value. So you can have like 0, 1, 2, 3, 4, all the way up to positive infinity. And then here you have negative 1, negative 2, negative 3, all the way to negative infinity. So you're going to have numbers on both sides. In the inequality questions that you're going to get, again, you're not going to be expected to draw up a number line because you're not going to be able to sufficiently demonstrate a number line when you're asked questions. So that's not going to be a part of it. All right, so normally as well, when you have an inequality, it's either going to be a greater than or equal to, or a less than or equal to. So these are inequalities, and they're called inequalities because you have the greater than sign, the less than sign, but you also have like an equal sign. So it's an inequality because you're a combination of the two. Normally, if you're representing inequalities on a number line, you either have, you typically have like closed loops. And the reason why, or closed circles, and the reason why is because it's an inequality that endpoint is always going to be a part of your answer because it's less than or equal to. So it can be less than or equal to that endpoint value, or it can also, it can be greater than or equal to that endpoint value, or it can also be less than or equal to the endpoint value. So typically, your circles will be pretty much enclosed if you have inequalities. If it was just greater than or less than, then you would have like open circles because the endpoint is not a part of it. Same principle here. If it was like greater than or less than, you just have like an open circle to indicate that the endpoint is not a part of it. All right, so with that being said, let me just go ahead and go through a couple of examples. All right, so the first one I have here, so I have 6, and then it's n plus 10, and I have my greater than or equal to 31. So really quickly, I know that sometimes students struggle with understanding if it's greater than or which one's greater than. So that's greater than or equal to, that one's less than or equal to. So normally, in order to kind of figure this out, you can sort of use your right and left hand. You can use your right hand to make make the curve. Whenever you are using your right hand, just know that the right hand will always indicate greater than the left hand, which is sort of pointing towards the right, will always indicate less than. Not really sure if that's helpful, but again, this is greater than, where it opens. So the greater than sign, as you can see here, it opens to the left. and the less than, it opens to the right. So that might be a way that you can differentiate between what's greater than and what's less than. So we have our 6 n plus 10, or 6 multiplied by n plus 10 greater than or equal to 31. So of course we have our 6 on the outside of the parentheses, so we need to distribute this term to the terms on the inside of the parentheses. If we're distributing a term, it means that we're multiplying the term on the outside with the terms on the inside. That's what it means when you distribute a term. So for example, here I have my 6 times n, which is 6n, plus 6 times 10, which is 60. And then I have greater than or equal to 31. And then, of course, all I'm doing is solving for n, so I just need to simplify. So I would end up with 6n, which is greater than or equal to, so I have 31 minus 60, which is going to give me a negative 29. Because I'm moving this 60 to the other side. So if I'm adding here, once I'm moving this over the inequality, I have to change the sign. Or another way to look at this is that if I'm trying to move 60 to the other side, I have a positive 60. If I subtract 60 here, I have to also subtract it here to maintain the inequality. So therefore, this cancels. So I have 6n, which is greater than or equal to 31 minus 60. And that is how I got my negative 29. So now that I have 6n is greater than or equal to negative 29, I'm solving for n. So I can divide both sides by 6. So I end up with n, which is greater than or equal to negative 29 over 6. So I ended up with an improper fraction. Here, you can just leave your answer as an improper fraction. If you get it like this, if you give me the answer like in terms of like an improper fraction or mixed number, either one would be acceptable. So I'll just leave it as n greater than or equal to negative 29 over 6, and that would be the final answer here. All right, so look at another example. So I have negative 21, which is greater than, so it's greater than or equal to negative 2m plus 7. So negative 21 greater than or equal to negative 2m plus 7. So again, I'm going to solve for the m right here because that's the variable in this situation, and I'm trying to figure out what m is. So I have negative 21 greater than or equal to negative 2m plus 7. So I'm going to put my constants together. So I have a positive 7 there. So pretty much I'm moving this to the other side of the equation. It's a positive 7, so I'm just subtracting 7 from both sides. So minus 7 there, minus 7 here. This cancels. Opposites always cancel. If you have a positive and a negative, those are additive inverses, so they will cancel. So I end up with negative 21 minus 7. That gives me a negative 28. And that's going to be greater than or equal to minus 2m. And then my last step here, I have a negative 28 greater than or equal to negative 2m. Here I'm multiplying by a negative 2. So in order to move it to the other side, I need to divide by negative 2. I'm dividing by negative 2 here. However, with this one, there's an additional step. And the reason why there's an additional step is that I'm dividing by a negative term. So when you have inequalities, if you're dividing or if you're multiplying by a negative term, you have to change your sign. So you have to reverse your sign. So this sign is now saying a negative 28 over negative 2 greater than or equal to negative 2m over negative 2. I need to change that sign to less than or equal to. And the reason why I'm changing that sign is that when you multiply by a negative number or divide by a negative number, what you're doing is that you're actually converting the sign that was greater than to a larger number. And therefore, because you're doing that, you need to invert your sign. So here, this cancels here. I have negative 28 over negative 2. So the negatives will cancel, or meaning that if you have a negative times a negative or a negative divided by a negative, it gives you a positive. Or you can think of it as canceling each other out. So I have a negative 28 divided by negative 2, so that just gives me a positive 14. And again, I have to change my sign because I was dividing by a negative number. So therefore, it becomes 14 is less than or equal to m. So once you multiply or divide by a negative number, your sign has to change. And that's because you are changing the terms on either side. So in this case, I had a negative 28. I have a bigger number now. So that's why my sign has to flip. So I'm changing the whole thing by multiplying or dividing by the negative number. So now this would be my final answer. So 14 less than or equal to m, or I can rewrite this as m greater than or equal to 14. Because saying 14 is less than or equal to m is simply saying that m is greater than or equal to 14. So I can rewrite it as m greater than or equal to 14. But again, if this answer was given, it would still be acceptable. It's still correct. It's just that you can always, like change it around to sort of make m the subject, since that's kind of what you're solving for. But again, either responses would be fine. 14 less than or equal to m, or m greater than or equal to 14 is correct. All right, so that's the second example. I'll do another example with inequalities. So I have 3 less than or equal to u over negative 3 plus 19. All right, so again, I'm solving for the u because that's our variable in this situation. So first things first, I need to move the farthest term away from u, which is the 19. Because as you can see here, I have u divided by negative 3. And if you guys think about PEMDAS, you'll notice that with PEMDAS, it talks about parentheses, exponents, multiplication and division, which has the same level of priority. Addition and subtraction, same level of priority. But in this case, we have division here, we have addition. So it kind of shows you, because these two have the same level of priority. When you're dividing something, it's more closely related than if you're adding something that you're dividing to a number. Because here, when you multiply or divide, you sort of want to keep these two together. So kind of when you're trying to undo an equation, let me put it that way. When you're undoing an equation, you're doing the reverse of PEMDAS. So instead of moving like the multiplication or division things first, you want to always move anything that's added or subtracted to your variable. So you're sort of going in a reverse order when you're undoing an equation. When you're solving an equation, for example, if you had 3 times 7 minus 4 plus 6 multiplied by 8 squared or something like that, that you'd have to use the PEMDAS starting from parentheses to exponents to all of that. However, when you're undoing an equation, you want to go in the reverse format. So you want to remove the things that you're adding or subtracting, followed by the things that you might be multiplying or dividing. So that's kind of why we're taking out the 19. It's the farthest away from the u. So I have a positive 19, so I just subtract 19 from here. I also subtract 19 from there as well. So these two cancel. So I have 3 minus 19. That gives me a negative 16, less than or equal to u over negative 3. So you might be wondering why I'm not changing the sign here. You only change the sign when you multiply or divide by a negative number. Since we're just subtracting a number, or sign is fine. So I have negative 16 less than or equal to u over negative 3. So now I'm going to go ahead and multiply by negative 3 on both sides. So I'm multiplying by negative 3 here as well. This cancels that. So I have u. Then I have a negative times a negative, which gives me a positive. Because if you have a double negative, it gives you a positive. If you have a negative and a positive, it gives you a negative. If you have two positives, it gives you a positive. But in this case, I have a double negative 3 times 16. So this gives me 48. And because I'm multiplying by a negative number, I have to change my sign or reverse my sign. So now I have 48 greater than or equal to U. And that's my final answer. Or I can also say U is less than or equal to 48. So either or. If you want to leave it as like this, it's fine. If you want to rewrite it with U as a subject, like U less than or equal to 48, or if you want to say 48 greater than or equal to U, it's saying the same thing. There's no difference there. And that's it for the inequality section. So for those students in this particular category, if you know how to do your inequalities, these are some of the questions that you'll get. And the questions will be projected on the screen, so you will see it. I'm not just going to read it and then you have to like write it down, but it will be projected. So you will be able to see the question and be able to really work it quickly. And then, of course, give your response. So I'm going to move on to the next category. All right, and this is for students who are 16 to 17. So the older students who kind of have a basic understanding of most of the math that you will get throughout high school, because when you're in fourth form, that is when you start the CSEC curriculum. And then, of course, in fifth form, you sort of get additional things. Things like maybe earth geometry, stuff like that. But fourth, fifth form, so it will be a situation where even if you're in fourth form and you haven't gotten to fifth form yet, it's stuff that you would have seen. So it's not going to be things that only fifth formers are aware of. That would not be fair. So you're going to see topics that you are pretty much exposed in fourth form. But of course, fifth form, that's where they kind of build on certain topics as well. So what I want to talk about is functions, and that's a really popular topic. That is definitely something that you'll see on CSEC. There's always like a whole section when they give you that part where you're choosing. You have maybe 5 or 6 questions, and they tell you to choose 2 and then work the 2. So we're going to look at functions. All right, so just a quick recap of functions. Remember that with a function, you can either have a one-to-one mapping, or you can also have a situation where you have a many-to-one. So you can also have a many-to-one, not a one-to-many, just a many-to-one. Because if it's a one-to-many, that's not a function. But again, you can have a one-to-one function, a many-to-one function. So say, for example, if I wanted to do something that was one-to-one, then I would have... So this would be one-to-one. Like I would have A, B, C, 1, 2, 3. 1 is going to 1. 1 maps onto 1. 1 maps onto 1. So A maps onto 1. B maps onto 2. C maps onto 3. So what this means is that in your domain, so this area is called your domain, and this is called your range. So if you have a one-to-one mapping, it just means that one element in your domain, it maps onto one element in the range. So it's a one-to-one because you have one thing going to one thing from domain going to one thing from range. If it's a many-to-one, that's slightly different because you have multiple going to one. For example, you can have something like A and B mapping onto 1. Or you can have a situation where you have A, B, and C mapping onto just 1, and then I'll just erase these. So this would be a many-to-one because you have multiple elements from your domain mapping onto one element from the range. It can never be a one-to-many because you can only have one-to-one or many-to-one functions. If it's anything other than that, it's not considered a function. All right, so with that being said, I'm going to go through a couple of examples. All right, so starting off with something kind of simple. So f of x, and f of x sort of just represents functions. So f of x is equal to 3x plus 2. And I'll also have a g of x that is equal to 2x minus 1. So 2x minus 1. So for the f of x one, I'll just start with, so calling this a, this b. So if I'm looking at f of x and I have 3x plus 2, what if I wanted to do f of 2? All I'm doing is that I'm changing the pretty much the variable x with the number 2, meaning that wherever I have x in the original equation, I'm going to replace it by 2. So I would end up with 3 times 2 plus 2. So again, anywhere I see the x in the original equation, I'm replacing it by 2, since instead of doing f of x, I'm doing f of 2. So I would end up with 3 times 2, which is equal to 6 plus 2, which gives me 8. So it means that f of 2 is equal to 8. And that's it for that one. So pretty straightforward there. And it's the same thing if I asked you, like I gave you a function and I asked you find f of 6 or f of 10. All you're doing is you're just replacing the variable x with whatever number it is that I'm asking to find f of, or the function of. So f of x equals 3x plus 2. I could ask you to find f of 10. So it'll just be 3 times 10 plus 2. F of 20, 3 times 20 plus 2. F of 15, 3 times 15 plus 2. And that's all there is to this one. I could also ask you as well about finding like a g of 9 or a g of 10 or whatever the case is. So say, for example, I ask you to find g of 7. So in this case, g of 7, again, looking at my original equation here, 2x minus 1, I would have 2 multiplied by 7. So replacing my x by 7. As you can see here, x 7. So wherever I have x here, I also have to have the 7 because I'm replacing it. So I have 2 times 7 minus 1. So it's 2 times 7, which is 14, minus 1, which gives me 13. So therefore, g of 7 is equal to 13. And again, that's all you need to do for this one. So again, you can also have like g of negative 1, g of 0. If it's g of 0, all you're doing is that you're just replacing the x by 2 by 0. So it'd be 2 times 0, which is 0 minus 1, which is minus 1. So a g of 0 in this case would just be equal to negative 1. So pretty simple there in terms of what you're replacing. So now a little bit more complex. So say, for example, again, these are my two equations, and I ask you to find like g of f of x or f of g of x. So I'm going to do both. So if I ask you to find f of g of x, so what does this mean? So I have my function and I have g of x, and I ask you to find f of g of x. So if you're finding f of g of x, like what you're doing is that wherever you see, so let me just rewrite my function. It's 3x plus 2. Wherever you see x, you're going to replace it by g of x, like the whole function g of x. So all that you would do here is that you'd have f of the function g of x, and that's equal to 3. So we're rewriting times our x, but no, instead of having x, we have g of x. So what is g of x? G of x is 2x minus 1. So it's 2x minus 1. And then we just write the rest of the equation, which is plus 2. So instead of having the 3x plus 2, I now have 3. Replacing my x with g of x, I have 3 times the 2x minus 1 in parentheses, and then I add 2. So here I would end up with, when I simplify, 3 times 2x, that gives me 6x. 3 times a negative 1, that gives me negative 3. So I'd have negative 3, but I have a plus 2 there. So I would get 6x, and it's a negative 3 plus 2, which is a negative 1. So my f of g of x would be a 6x minus 1. And that would be my final answer there. So that's the answer simplified. So f of g of x equals 6x minus 3 plus 2, which is 6x minus 1. All right, so we can also do g of f of x. So pretty much just doing it the other way around since I have both functions. So if I have g of f of x, so this is my g of x, which is 2x minus 1. So I'll end up with 2 times f of x. So this is g of f of x. So wherever I have x, I replace it with f of x. So now I would have 3x plus 2. So 2 times 3x plus 2 and then minus 1. So g of f of x, I just remove my x and I put the function f of x, which is 3x plus 2. So here I simplify. So I have 2 times 3x. That would give me a 6x plus 2 times 2, which is 4. And then I have my minus 1 here. So I end up with 6x minus 3 because 4 minus 1 gives me 3. So g of f of x is equal to 6x minus 3. And that there would be the final answer. So 6x minus 3, or g of f of x, is equal to 6x minus 3. So these are the kinds of questions that you will get regarding functions. So of course, being able to look at a function and then do things like f of 2, f of 2, f of 3, f of -1, f of 0, stuff like that. Just plugging in values, but also being able to do like an f of g of x or an f of x. Or g of f of x, being able to solve stuff like that. So hopefully this was helpful. Let me see if I had any other examples. All right, so I don't have any other examples. These are the examples that I wanted to kind of show you so that you can kind of see the format of the questions that you will be getting. So hopefully this was helpful, and we're also going to have another session next week. I'll try to tackle some other topics that you will see on the actual competition, the list of questions that we formulated thus far. So it'll be easy for you guys to navigate through as we do the competition. We're also, of course, going to have the prep sessions, as I've stated before. So we'll reach out to you, but we still have the competition. It's still the application process is still ongoing, and we want to send out like a mass email. So we're kind of waiting until the 7th, and of course, after the 7th, once we formulate everything, we will reach out to you guys to let you know exactly when we'll be meeting and stuff like that. So you will be getting more information in the coming days. So stay tuned to our social media platforms so that you can see the updates, and then of course you can kind of see the next steps as it relates to the application process. I do know that a lot of persons have a lot of questions and so on, but all those questions will be answered in due time. So you guys will be hearing from us pretty soon. So just give us some time until, of course, the application process closes, and then you will be able to get a better understanding of the expectations, guidelines, and things like that. So again, I want to thank you all for joining me this evening. I do appreciate the time that you took to come on to the program. In addition to that, I'm also again going to thank our sponsors who have come on board to, of course, ultimately make this competition a success. So I want to thank again Mr. Wright. That's Mr. Dennis Wright, Miss Nicola Myrie. I want to thank you for your support. I want to thank Miss Lashana Morgan. I want to thank Miss Ruth Porter and Miss Daislyn Facey for their support. And as I've stated before, if you'd like to support this competition, you can always reach out to us and let us know. And of course, we welcome any support, additional support that we can get as well. I'm looking forward to meeting all of you on Zoom come pretty soon. So as I've stated before, stay tuned. We'll reach out to you guys with the information for the next steps. And I do hope that you guys enjoy the rest of your evening. Thank you so much for joining me this evening. And I hope this session was helpful.
You already started? Nobody not come out.
Damn it. Hala,